In our first celebration of learning problem, we have Ben, Nathan, Mike, and Art played in a chess tournament over a period of 3 days. Each boy played each of the others exactly once, and each boy played once per day. Mike played Nathan on day 1, and Nathan played Ben on day 2. Find the game schedule of the tournament and justify your answer. First, what I like to do always is pull quantities and their values. And so we know some things so far. We know that there are 4 boys in the tournament. Their names are Ben, Nathan, Mike, and Art. They played in a 3-day chess tournament. Each boy played each other exactly once. Each boy played once per day. Mike played Nathan on day 1, and Nathan played Ben on day 2. Since we know that each boy played once per day, we know there will be 2 games a day for 3 days. We'll use a table to organize what we know in the next slide. So far what we know is that the tournament will last 3 days. Each day there will be 2 games, and so we'll make a table with the 3 days listed at the top and 2 boxes below it to indicate each game, game 1 and game 2. So we were given some information in the problem about day 1, and that was that Mike and Nathan played. Since Mike and Nathan played and they can only play once a day, that leaves Art and Ben to play. We were also given information about day 2. On day 2, Nathan and Ben played, so that leaves Mike and Art to play each other on day 2. So for day 3, we're gonna pull Art and we're gonna look at who he hasn't played yet. Art has not played Nathan, and so he's gonna play Nathan on day 3. And in the second game, the 2 players left that have not played each other yet in the tournament are Mike and Ben. We can double check our work and go over the days and make sure that nobody plays each other twice in the tournament, and nobody plays twice in a day. Mike and Nathan, they don't play anywhere else in the tournament, so that's correct. Art and Ben don't play anywhere else in the tournament, so day 1 is fully correct. Day 2, Nathan and Ben play in the first game, and Art and Mike play in the second game. Those matches don't play anywhere else, don't play each other anywhere else in the schedule, so that's correct. On day 3, Art and Nathan played. They aren't seen anywhere else playing each other on the schedule, and neither are Mike and Ben. Our final schedule for the 3-day chess tournament for the 4 boys is on day 1, Mike and Nathan played, and so did Art and Ben played each other. Day 2, game 1, Nathan and Ben played. Game 2, Art and Mike played. Day 3, Art and Nathan played, and Mike and Ben played. For our celebration of learning problem number 2, we have a candle that has been burning for 2 hours and is currently 13.5 inches tall. 4 hours later, the candle is 10.5 inches tall. How tall was the candle originally? Identify all the relevant quantities and their values, whether known or unknown in this situation. Determine any relevant relationship between these quantities. Use either a diagram or structured guess and check table to solve this problem. So what we're going to do first is pull quantities and their values. So far what we know is that the height of the burned candle after 2 hours is 13.5 inches. The height of the burned candle after 6 hours is 10.5 inches. The number of inches burned in 4 hours is 3 inches. The number of hours that the candle was burning is 6 hours. And we also have a quantity of the number of inches burned in 1 hour, which we don't know, and the height of the unburned candle, which is what we're trying to figure out. We're going to use the height of the burned candle at 2 hours and at 6 hours to help us find the number of inches burned in 1 hour, which will help us find the height of the unburned candle, and which will help us solve the problem. To determine how fast the candle is burning, we need to figure out the rate of burn. We're going to use a guess and check table to determine the rate of burn. First, we're going to start in hour 2. In hour 2, we are told that the candle is 13.5 inches tall. First, we will decrease the height of the candle starting at hour 2 over the course of 4 hours until we reach 10.5 inches at hour 6. So for our first guess, we're going to begin by guessing that the candle burned 1 inch per hour for 4 hours. The candle could not, so if we start at hour 2, we do 13.5 inches minus 1 inch. That gives us 12.5 inches at hour 3, hour 4, 11.5 inches, hour 5, 10.5 inches. The candle could not have burned 1 inch per hour for 4 hours because the candle would have been 10.5 inches at hour 5 and not hour 6. That is too fast of a rate of burn, so we know that 1 inch is not a correct solution. We're going to go, or correct rate of burn. We're going to go to our second guess in underneath hour 2, and we're going to decrease our guess by a little bit because 1 inch was too much. It burned too fast, so we're going to decrease it by 1/2 inch. Guessing that the candle burned 1/2 inch per hour, and so hour 3 we have 13.5 inches minus 1/2 inch, which gives us 13 inches. 1/2 inch minus 13 inches in hour 4 gives us 12.5 inches. Hour 5, we see that 1/2 inch minus 13 inches is 12 inches. This is burning too slow, and so we won't get to the 10.5 inches at hour 6. This isn't this isn't the correct rate of burn for us. Our third guess is going to be a little bit above 1/2 inch and a little bit below 1 inch. We'll see if we can find a sweet spot in between those two measurements. Our third guess is that the candle burned 0.7 inches per hour for 4 hours. The height of the candle, so if we decrease 13.5 inches by 0.75 inches, we will get 12.75 inches for hour 3. Hour 4, we decrease 12.75 by 0.75, we get 12 inches, and 0.75 minus 12 inches is 11.25 for hour 5. We decrease that one more time for hour 6 when it was measured, and we get 10.5 inches. That is the desired height that we are looking for. So our rate of burn is 0.75 inches per hour for 4 hours. Since we know that the candle burns 0.75 inches per hour, we can use this information to determine the original height of the calendar. We're going to go the other way on the guess and check table. We're going to increase the height of the candle by 0.7 inches per hour for hour 0 and hour 1. Hour 1, we have 13.5 inches plus 0.75 inches, which gives us 14.25 inches. Another 0.75 inches on top of 14.25. We see that the final height of the candle is 15 inches. We can also, the guess and check table gives us the rate of burn and a final unburned candle height, but we can plug this information into a diagram, and sometimes diagrams help people who learn a little bit more visually. And so, and again, double check your work. It's always good to have a few different ways to show your work. So we using this information from the guess and check table, we can see that the candle decreased 0.75 inches per hour for 4 hours and reached 10.5 inches at 6 hours, or hour 6, sorry. Since we know that the candle burned at a rate of 0.75 inches per hour, we can add 0.75 inches to hour 1 and 0.75 inches to hour 2 to reach the height of the unburned candle. The height of the unburned candle is 15 inches, which is what we were asked to find. We were asked to find the height of the unburned candle. In our celebration of learning problem number 3, we have Elena is trying to explain why 3/7 is less than 5/9 to a student. They make use of the following diagram that's listed below. Their explanation is as follows. So the top diagram shows 3/7 and the bottom diagram shows 5/9. They're both missing 4 pieces, right? but more of the 5/9 is shaded in than the 3/7. So that's how we know 3/7 is less than 5/9. What is potentially misleading about this explanation? What could the student teacher change about their explanation so that is no longer misleading? We can use any strategy we like, any strategy you like in changing their explanation. And so we were asked a question why their explanation is not a sufficient solution. We have a few explanations of that, or a few. I pulled a few points from why it's not a sufficient explanation, and that's because the diagram that the students are using is misleading. Is the misleading part of this solution. In the diagram, the students are not considering the same whole. Even though the fractions, numerators and denominators are different, we must use a diagram where the fractions are considering the same whole. Comparisons are only valid between fractions when they are considering the same whole. To correctly compare these fractions, we need to create a diagram that shows the same base shape with the same area. We will use a pie graph to correctly show that 3/7 is less than 5/9. We can compare fractions by seeing which one takes up a greater portion of the same whole. So we're going to use these two pie graphs. On the left, we see that 3/7. We see 3/7, and we know that it's 3/7 because 3 pieces of the pie are shaded and 7 are left unshaded. On the right, we see 5/9, and we know that because 5 pieces are shaded and 4 are not. So now we're going to decide which fraction is bigger by comparing the pie graphs, which is what the girls should have done originally. They should have used something, they could have even used like blocks that were the same size, but whenever you compare fractions, they have to be the same size. They're the same area and the same size. So we have our two pie graphs here, and so we must compare them with the same base and the same area. While comparing fractions, we are considering the whole and its parts. In the 7-piece pie graph on the left, 3 out of the 7 pieces are shaded. In this pie graph, less than half is shaded. We can see that clearly. In the 9-piece graph on the right, 5 out of the 9 pieces are shaded. In this pie graph, more than half is shaded. Using pie graphs, we can see that less than half of the circle is shaded for the fraction 3/7 and more than half is shaded in 5/9. In these two fractions, 5/9 takes up a greater portion of the same whole.